Hello there, so my name's Danny, and today we're going to have a look at the ultimate video editing server. So here goes, right? So come with me. Right. And what you'll see is a world full of imagination. Right. So what we have here is possibly one of the best video editing servers I've ever created. Why is that? Well, because it contains two P100s, which are right there, a 32-core EPIC CPU. I was going to say server, but this is actually a CPU. And we've even got a 1600-watt power supply, the Seasonic Prime, which combined all together means we can get up to some mischief and mayhem. So, what does this enable us to do? What this enables us to do is create virtual machines, which is great. And on top of that, we can use those virtual machines with the graphics cards, the P100s, in Proxmox to get stuff done. And in my case, I'm going to also install a 25 gigabit card, so that's the Intel E810 full port. And what that's going to do is enable us to get some serious amount of speed through into the VMs, which is 25 gig, into that 100 gig switch, and on top of that, we'll install Proxmox and get some stuff in there as well. So join me for that journey. First of all, what I'm going to do is I'm going to install the card in here and show you that, and then I'll show you the setup into the switch, and then on top of that, we'll go into Proxmox and do the graphical install, and then after that, once that's done, we'll set up the VM for Adobe Premiere and all that kind of good stuff as well. Alright, so that's going to be the format of this video. Like and subscribe, and I'll see you in a bit. Alright, in front of me, we've got the card itself, which is the Intel E810 XXVDA4. It's one that I bought off the eBay. SFP28 quad port, right? That's going to go in there, right? The power's off and all that good jazz. So here we go. So let's open this up. There we go, we've got the nice manual there. What's this? Methods of micromanagement, stuff about pollution. Alright, sweet, but that's not what I'm interested in. I'm interested in this. Right, so here's my card, and the box has decided to move. Fantastic. And right, what have we got here? So is this what we said it was? Yes, good. Okay, some plastic, great. Okay, cool. So let's open this up. Right. Two hands for this job. My cameraman's gone on holiday. And right, first things first, let's so this is how you know it's real, right? Just one person in his room, cameraman's buggered off somewhere, and you're an angry sysadmin that needs to do everything. Right, okay, cool, so that's it. Here we go, and then the way that you insert this is by going over to the other side of the living room, minus the fan, so that fan will become important in a bit. But for now, right, here we go, right? So for anybody who's wondering how I'm going to install this, you see we've got these 3 PCIe slots down here, right? So 2 of them are X16. This is an X16 slot because it's full length, right? And then what we do is we just put it in there. I'll show you what I mean in a minute, right? It's going to be a bit awkward this because I haven't got any place to put this, so just bear with me a moment as I kind of get this in the right place. Right, I'm back once again. Excuse the noise outside, there's some lawnmower stuff going on. Right, okay, let's try this again. So, simply just put it down here. And let's get this lined up. Ow. Use my other hand for this. Right, like that. Okay, and it should stand up like that. And now I should just be able to slot it in, but I can't see if I'm aligned. I should be. It looks like I'm aligned. Okay, it looks like I'm aligned. I should just be able to slot it in like that, right? Okay, and to check that it's aligned, we look at this little hole here, right? So usually it will be empty, or you will have something populated here. But because it's empty, we can see that the hole is there and it's aligned nearby the graphics card. And I don't care that it's near the graphics card. The reason why is because these are blower style graphics cards. So in other words, you're supposed to blow air into them via the chassis of the case. And this isn't the correct case, unfortunately, because the correct case is actually more similar to that over here, because this particular case has blower style fans which go into it. And I'll show you what I mean by that, right? And now that we've got that card in, but I'll show you what I mean. So the type of case fans that we want is closer to this, right? Which blows air into the system, because this takes air from the outside, pushes it back in, creates the pressure within the system, and then that gets pushed out the back through the fan at the back, right? And that's essentially what we want. So now that that's in, I don't think I need any external power. That looks all good, right? And at the back, this is what it looks like. So it will look like this. Hello, Mr. Cameraman, what are you doing? Come on, Mr. Cameraman. Okay, the cameraman's decided to be a bit weird. Come on. Gimbal up, gimbal up. Okay, he's decided to be a bit strange. But basically that's what it looks like, right? We've got the 4 SFPs down here. And that SFP down here will then connect in... Sorry, these SFP28s even will connect in with SFPs, and then that will give me access to my network. Okay? And I'll show you how that works in a minute. Okay, so the next part of this project is I'm going to connect up the QSFP28 with these SFP28s. You've seen this before, so I'm not going to kind of repeat myself here, but essentially we're going to connect this up to the PC and onto the switch. And what I'm going to do to ensure that I know which one's which is I'm going to connect only one of these SFP28s into the server, so that way I know which one's which, because when we get to Proxmox, we're not going to know exactly which one is up and down, because we're going to be carrying separate traffic on these SFP28s, and we need to know which SFP corresponds to which port in the virtual switch. At least I think that's how Proxmox works, but we'll find out in a second. And once we know that information, then we can attach the other 3, which will give us the equivalent of 100 gigabit worth of bandwidth, right? Because remember, these ones are aggregate, right? These aggregate to this 100 gigabit SFP28, QSFP28 even. So, yeah. Cool, I'll see you in a minute. So it comes like this. So get it all in frame, please. Thank you. Comes like this. Get rid of that. And then you get like this, right? So open it up. This is the AOC cable. And here's what we're going to do. Take one of these out, one of the SFPs, which is this one. So all 3 meter cables. I'm just going to take them all out of the case. Okay. You didn't see that, and and then we're going to just put one of these in, right? So very, very simple process. I'm just going to put these down here, take it with me, and switch around the camera. Okay, let's see, where is the cable gone? Should be in view. Oh, there we go. Right, okay. So here's literally what we do, right? So we've got one of these ports down here. Got one of them like this, so I just want to check, is that going to go in that way or the other way? It looks like the other way to me. Okay, I don't hear the click, so I've got to turn it around, and it should just click in without any force, like that. Okay, let's go over to the other side, and I'll show you that process on the other side as well. Pretty much the same thing, but you might want to see it from that perspective, so I'll show it to you. Okay, down you back here again. So you join me now at my server closet, if you like, and essentially that's the QSFP down there in the Arista. That's the 7280TR 48C6. That's the make and model of the Arista which I have here. I was thinking about getting the fibre optic version, but yeah, probably in a later video. But essentially, what we're doing is we're going to put this QSFP directly in like this. Okay, I've got it the right way around as well, because, you know, back from the Absence Part 3 video, which will be coming out at some point, I've just got to get the software bit kind of tied in, and essentially all it is just in like this. Get my hand in there, and there we go, like that. I think that's now connected, although it's not enabled, which is why the if you look down here, a bit of extra information for you. You see how that one's green and that one's orange? Right, that's because it's not enabled just yet. I need to enable it within the interface of the 7280. In other words, I need to go into the CLI and then tell it what I need to do with the speed. That's the most important part in order for it to be enabled, right? As long as the firmware is burned into the SFPs, so in my case they are, I've got the QSFP28 on this side, which has got the Arista firmware, and then I've got the SFP28 firmware on the other side. So in theory this should all work fine. I just need to get it all configured now, so join me as I get it all configured. Right, so we'll be on the computer in a bit, and that's going to be where the fun happens. Alright, see you in a minute. Bit of a change of plan in this video, because I had assumed that I needed 7.1. What I found out is that that's not the case. 7.4 has the same kernel as 7.1, which is 5.15, right? It's when we get to version 8.2, which will happen soon, because version 7.4 of Proxmox ends on the 26th of July, 2024. The 26th of July, 2024. Right? Which is about a month's time. So why is that important? Well, we've seen that the new driver, which is 16.6, has already been released. So we need to wait for that driver to be patched in order to use it for our Proxmox server. Now, when that driver gets patched, I suspect it will be compatible with 8.2 of Proxmox, which uses the 6.5 driver. Sorry, not driver, I mean kernel, the 6.5 kernel, right? So when it uses the 6.5 kernel, then we can use that 16.6 driver, which is our NVIDIA driver, and then we'll be able to have that long-term support that we want. Okay? So that's that part out of the way. So what are we going to do in the meantime? Well, in the meantime, we're just going to use Proxmox 7.4 because it's a supported Proxmox version, which supports version 16.5 of the NVIDIA host and guest drivers. So that's what we're going to do. Right? So first thing that we need is that we need Rufus, right? So Rufus is going to create a bootable USB for us. And I'm just going to take my USB out and plug it into my system. Okay, and let's download Rufus now. Okay, and in here, got Rufus 4.5, click yes. Okay, now let's go back to our directory where we downloaded Proxmox 7.4. So I'm going to have a look at that, and I just have it conveniently located here. Okay, I'm just going to click start. I'm not going to mess about with any of the settings, just simple plug and play. Don't need to overcomplicate it. Let's just put 7.4 in. We'll wait for that to write. It shouldn't take too long, should take about a couple of minutes. Okay, and our Proxmox image has been created. We'll click close on that, and we're just gonna put it into the Proxmox server. Stay tuned. Okay, so we're going to access the BIOS now because I put the USB in. So we're going to access the BIOS. Just going to wait for this to reboot. I'll just turn it on to make sure the fan is spinning, which it is. So it should be turning on now. Yeah, there we go. Dell, so I've got a super micro board in here, but it's pretty much the same process. We'll Dell on that. Okay. So inside of the BIOS, I know you can't see it very well, but I will essentially say what it is. You go to Advanced, and in here you want to enable some of the features for virtualization. It's like SRIOV, you want to enable IOMMU support, for example, that sort of thing. So what we're looking for in here, and I believe it's an MB configuration. Yeah, so IOMMU, ACS enable is one of them. Leave the rest to auto. So those are the two that I've made, and I know that there's one more which is in here, which I made, and it was something to do around SRIOV, but I don't remember exactly where it is in here. Let me just check. And I think it is in CPU configuration. Oh yeah, SVM mode. That was another one, I think. Yeah, SVM mode enabled. That was another one. SVM mode has to be enabled as well. And that's 3. There's one which was SRIOV, and that needs to be enabled as well. Which I think is in here. Yeah, here it is. SRIOV and above 4G decoding. You need these enabled in order to virtualize the card, and a lot of content creators haven't said that. I've had to figure this one out myself. But these are the settings that you need in order to not only allow for proper virtualization from the hardware side, so in other words from the CPU, but you also need it to allow the graphics card to be virtualized as well, because some graphic cards support SRIOV, I know the P100 does, and that allows you to share the resources across the VMs. So in other words, the graphics card has a certain amount of memory, and in order to share that memory, you need to have SRIOV enabled. Okay, cool. So that's the first part. Now the second part is that we need to go to boot, and in my case, it's on the Kingston Data Traveler, and I need that partition. So I'm going to boot from that partition and exit. So if I go to save and exit under boot override, I want that under partition 2. So I'm going to select partition 2. There we go. Get the words out today. I know it's a Sunday, so it's not the best. And then we install Proxmox. And this should allow us to install correctly now. Takes a bit of time. That should be all fine. Okay, let's see if I can get this a bit closer to the screen as well for you guys, so you can see what's going on. Get rid of that fan. We will need that soon as well, but that's when the VMs are running. Right now they're not. Let's get rid of some of this stuff as well. Okay, cool. So hopefully you can see that screen and it's in view. Just put this down. I don't have a cameraman, otherwise this would be a lot easier. But I'm editing on a shoestring budget as well, so apologies. Right, okay, so let's install this, shall we? Where's this cable? Right, cool. Right, okay, now I've got the mouse in. Let's go to I agree. Let's get our target drive up, which is the 1 terabyte. I don't have any other options in there. Let's check the options. Okay, that's fine. ext4. Can we do ZFS? Oh, you can. Wow, okay. So we've got ZFS and BTRFS. I'm just going to keep it simple and go with ext4. No need to overcomplicate. I'm in the UK, so we'll do United Kingdom. United Kingdom, time zone Europe, London, United Kingdom, looks all good. Password is my password. And then for the email address, I'm going to type my email address in. And of course I'm going to edit this out later. So yeah, alright, cool. And for this bit, I like to, you have to kind of play around with this a little bit, because sometimes it's not right. Now, because I've added the card in, it's gone in and given us these 4 interfaces here, called ICE. Now, ICE, as you remember, or you may not remember, but essentially ICE is the designation for the 25 gigabit NICs that I've got in there. So in other words, the kind of SFP ports. So it's pretty cool to see that it's supported. But in my case, I would just want EN02 as I plugged in my Ethernet adapter in there, essentially. So in other words, I plugged in my NIC. I can't get the words out today, can I? Right, I plugged in my Ethernet cable in there. That's what I'm trying to say. The EN02 is where I plugged in my network cable. So let's make a proper name for this. I'm going to call this proxmoxtest.com. For the FQDN, you can call it whatever you want. It doesn't have to be anything which is online. You can have it online if you want, but I use local names and they work fine. The IP address is going to be part of my network, so 192.168.10.0 should actually be the side though. Really, that's the, oh sorry, this is the IP address. This is not the subnet. Okay, that's 10.1. Sorry, 10.249 even for me. Just any kind of IP address from the subnet. The gateway for me is going to be .1, and the DNS server is going to be the same thing. Okay, cool. So for me, that's great. Let's click on next. That looks all good, and we'll automatically reboot after a successful installation. Let's click install. Okay, this part of Proxmox shouldn't take too long, seeming as this is a pretty quick system, 32 cores on this, and 128 gigs of RAM, so with NVMe on it as well, so should take relatively quick amount of time, about 2 minutes or so. So let's see how it goes. Here is a transition to the software. Let's go. Hello and welcome back to this episode of Multi-Tech Spec, where I'm going to install the NVIDIA driver for our VGPU. So I've got a couple of P100s, and my goal is to try and make this into like the ultimate video editing server. So my plan is to use Proxmox, use some P100s for that particular goal, and then on top of that aim to run Kubernetes on there as well. So I want to use it as a development environment as well. So those are kind of my goals with this particular machine that I have. But in order for me to get onto that level, I need to first install the NVIDIA VGPU driver for my P100s and add a patch onto them, so that way they work within Proxmox, which is my hypervisor of choice for this particular project. Reason being, well, it's quite well defined and there's quite a lot of information as to how to get these things working within Proxmox. So, first things first. I've installed Proxmox, so you'll see a little section on that before you come to this part, because I'm recording this a little bit out of sequence, but you'll see that as well. And on top of that, other things that you need the driver. So there's an official website for the driver, and the official website I have over here, which I'm using as UI licensing.nvidia.com, and the driver that we're looking for Proxmox you can find under the filtration of the product family as VGPU. If you do platform, the one that you want is Linux KVM, and then platform version, all supported, and then the product version, which is in my case 16.5. If you get stuck with this, there is a designation, so you can actually understand which particular product version you require, and I think it's even referenced in here. So if I go to this list, this kind of tells you which one you need for your graphics card. So this is docs.nvidia.com/grid, and in here it tells me, if I look for my P100, it should say down here, let's have a look, P100, there we go, Telsa P100, and we can see that it's in the second column, which supports it, and that is VGPU 16, right? So that is where I got that number from. How did I understand I need 16.5? Well, that's how I knew. And on top of that, if I want to see which particular virtual machines are supported, so in other words, with Proxmox, there's a particular type of Windows environment, Linux environment, which I can virtualize, right? So I'm going to be looking at the particular software release family, which in my case is 16. So if I look at this particular document, I can begin to understand which particular versions of software I need to use in order to virtualize certain types of operating systems. So, for example, if I want to virtualize Windows 11, I require software version 16.4 in order to do that. And with the way in which Proxmox works and some of these hypervisors, you first need to install the host driver, right? The host version of the driver, which is the VGPU portion to install on Proxmox, VMware, Zen server, that particular portion, and then you need to patch it with the particular patch for that software version, so 535 point something or something of that nature, and that will then allow for communications with the guest driver, so there's a guest portion, in order for you to successfully virtualize the VGPU with a preferred profile. So the actual P100 which I have has something called mdev types. Now these mdev types are profiles which I can use in conjunction with SRIOV, which you would have seen a little bit before in this video where I went into the BIOS. You'll see that when these mdev types are found within the system, these are the profiles which are working in conjunction with SRIOV in order to allow me to then split the video card, so that way I can allocate something like 8 gigs of virtual RAM to a virtual machine, or I can split it into having 16 different types of virtual machines which have 1 gig of RAM. It's really up to our preference at that point. So that's what this allows us to do, is it allows us to understand what type of driver version we need for our different purposes. And on top of that, we also have things like CUDA toolkit as well, which we can use, and other types of various features which our card supports. Okay, so that's the purpose of this documentation. So if we look a little bit through this, let's see what we can gather from it. So we can see that, you know, hardware supported since 16.3, there are different types of hardware. So yeah, so when selecting a graphics card for virtualization, one of the things that's quite interesting is to see whether or not the latest driver version, so 17.2 in this case, as out of the time of recording, supports the graphics card. Because what NVIDIA likes to do is deprecate some of the older architectures which they deem as no longer useful, right? So it ends up in hands like me, the hobbyist, or the consumer, the prosumer, who have an active interest in terms of virtualizing these particular devices, and also reusing them for different purposes, right? Because we can use them for things like video editing, things like Kubernetes, Docker, these type of different applications where we can take advantage of this raw power that's within these cards. Now, of course, because these cards are actively cooled, sorry, that's a bit of a misnomer. They are passively cooled because they don't have any sort of active cooling system. So in other words, they don't have fans, they don't have liquid cooling, that kind of thing. We need to ensure that adequate cooling is given onto the card. So before you start doing anything in terms of logging into the Proxmox server, or even doing the SCP of the driver, that sort of thing, just ensure that you have adequate cooling within your case, because these cards will get hot. And I've tried to record this video a number of times now, and I've come to the conclusion that I have to have the fan on the graphics cards in order to keep them cool enough so that they're found in things like LSPCI. Now, why is that important? Well, if it's not found within LSPCI, the problem becomes that the graphics card driver will then say, right, okay, you don't have anything inside of the system, and therefore when you try to do things like installation of the mdevctl types, or the mdev package in particular, you won't be able to see these particular profiles, and on top of that, you won't see the card. So you'll be left with even more confusion. So I've resorted on this particular take to just have the fan working as I'm talking. That way I don't have to worry about cooling of any kind. And of course, when I get a proper case for my setup, then that becomes an absolute non-issue. Right, so now that we have the semantics out of the way, let's go back into the software installation. And one of the things that is quite prevalent within this setup is knowing which version of Proxmox we have, right? So one of the commands that we can do in order to understand this is use the uname flag, right? So the uname, and the flag that we're looking for is -r. Now, why do we want the -r flag? Well, this tells us the particular kernel version that we're dealing with. Now, in my case, this is 515.102. Now, this is very prevalent because 515.102 is an older kernel. This is not the one that you're going to find within 8.2 of Proxmox. This is because I'm using version 7.4 of Proxmox. I'm not using the latest one. Now, why aren't I using the latest one? The reason why I'm not using the latest one is because the 16.6 version of the NVIDIA driver doesn't currently have a patch as of the time of recording. Now, in the future, it will do, because I believe that particular version is suited for Linux kernel version 6.5. Okay, and that's the version which I believe is on versions 8.2 of Proxmox as of the time of recording. Now, to get back to this particular guide that I have here, which is from Polo Loco. Great name, by the way. To get back to this, the reason why I'm on the 7.1 branch of this guide in GitLab is because this is designated to the same kernel. So 7.1 of Proxmox utilizes 5.15 kernel. So how do we check the Proxmox kernel version? Well, we can have a look at the changelog. So if we look at the changelog, we can see the different types of kernel versions which are applied to different versions, right? So let's have a look. So this is the main branch of Proxmox. There isn't any other particular branches or tags. So that's the one thing that we can check. But what about the kernel version? So let's see, kernel pin, new script. So we've got a couple of things there. We've got 12 here. So let's have a little look. So we've got Proxmox 7, Proxmox 6.2 kernel there. So we don't see much in terms of it, but 24.04 was added in for May. So we should be able to see the different kernel version, but let's just have a look. If not, we can always do a Google search to find out. But we should see that somewhere. Okay, it doesn't look as if it's in there. So, next thing that we could check is the release notes. Assuming that there even are any. There should be. Let's have a look. What's new in Proxmox 8.1? There we go, Debian Bookworm, new kernel version 6.5. There we go, so that confirms what I was saying. Uses the new Debian version there. Now can we see there we go, it's the roadmap. So if we look at 7.4, there we go, latest kernel is 5.15, and it's based on the bullseye of Debian. So in other words, version 11.6 utilizes bullseye. And that's another reason that I've gone to 7.1, because if we look at some of the codes that we're putting in, you can see that it's suited for bullseye. That is the reason why I've selected this, and it's very important that you have an understanding of this before attempting these particular upgrades. So what we need to do now is ensure that we have looked at this particular documentation. So in other words, go to this link here, and that will also be in the description as well. So if you're following along at home, you have something similar to this. I'll put this in here for you as well. This is the one that I've used. This is the one that I'm pretty sure works based upon my installation experience. I've managed to install it before, so I'm just going to go based upon my principles and say that it works. So I'm going to do a straight up copy and paste. So there's nothing new here, but what we can do is go through the reasons why we're doing this, right? So we are currently copying this line of code, which is to append to the sources list. And what this does is that this gives us the access to the PVU node subscriptions. So we don't have the enterprise repo. So if I was to do a simple update, so apt update, for example, it will fail because this particular repo is unauthorized. We don't have a license for the enterprise, so we don't need it within our app sources list because we're essentially finding something that doesn't exist. We don't have the access to it. So what's the point of it being there? There is no point. So what we need is a no subscriptions, and we'll put that into our app sources list. Next thing to do is that we're going to remove that enterprise list from this path, which is in sources list.dpv enterprise, because we don't need it. And we'll go back and update the distribution as well as update the system in its entirety. Now, one thing that we can do to be a bit sneaky is that we can add or append the next command, right? Because apt update is running a sudo. We don't need sudo in this case. I'm very used to running a sudo in the sense of running sudo apt update as a different user, not as root. So for me, this is nerve-wracking because working as an ex-Linux systems admin, see, I can't even get the words out, ex-Linux systems admin, one of the things that we were taught very, very early on is do not run as root if you can help it. So I kind of live by that mantra, and I don't like running as root. But in this case, I've only got root user on here. So it's being used by most of the system. It's a test machine, so I'm okay with it. But in production, try to avoid running as root if you can. And in most of the times, if depending on your vi sudo permissions, you won't necessarily be running as root anyway or have the ability to. And that depends on things like PAM permissions. So let's go and do apt-dist upgrade. And I'm not going to append with Y because it's bad practice, but you can append with Y if you want to. Okay, let's see our packages. That looks all good. I can't see any reason as to why we shouldn't install, so I think I'll do Y. And that's the reason why we don't use the -Y flag, because you want to have a sense of what packages are being installed within the system. And it makes more sense, right? Because you might not know that you're installing a package from a malicious maintainer, and that can be detrimental, right? Especially if you're in production, that could be the loss of your job, right? So why take that risk? Okay, so this is going to go a bit forward now, and I will pause the video here and come back when it's done. Okay, so continuing on, we've got PVE headers. So what I'm going to do is I'm going to copy this and put that there. Okay, I was a bit quick with that one because I was going to take out the Y, but let's just check. We have some good packages, so that's fine. I'm happy with that. Cool. And the other thing that I want to do is try and do this, negate the Y if I can. Okay, cool, that's fine. And let's negate the Y and see what it says. Okay, so we got some libraries being installed. mdevctl, right? Okay, yeah. So mdevctl was what I was talking about. That's the command that gives us the types, which gives us the ability to then, when using conjunction with the VGPU script, allows us to see the different profiles that we can use. So let's type Y for that, and let it do its thing, and I'll come back again when it's done. Okay, so the next step is to compile the Rust compilers. So in other words, we've got to compile a bit of code, and what this does is this unlocks our GPU, our VGPU, so that way we can use the profiles. Now, the one thing that I'm going to check before I go any further is to check whether or not my actual graphic cards are working, right? I think that's a good step. And I should have done that first, if I'm being honest. So, how do we check? Well, there's a command called lspci. Now, lspci shows the different... What's the best way I can explain it? It shows us, right, okay. It lists all the PCI devices within the system. Like, that's a better way of explaining it. And in fact, let's do a man lspci, right? lspci. Now it says, is a utility for displaying information about PCI buses in the system and devices connected to them, right? So that's the lspci command. Now, the reason why I say it lists the PCI devices which are connected to the system is because ls in Linux means list, right? So you say ls list, and in PCI I think, right, okay, a device, right? PCIe device, that sort of thing. Now, buses makes a lot more sense actually in the context. So listing the buses and the things which are connected to them. So there you go, that's lspci. Now in my case, I have the P100s, right? So if I grep lspci, if I wanted to consolidate this all down and search for just that, using the global regular expressions, which is what grep is, I can use P100, and for some reason that's not found. Let's try again. P100. There we go. It sees 2, which is exactly the amount that I have in there. Okay, so for case sensitivity, what we can do is try an extended grep. Or maybe not. Or maybe not in this case. So that's interesting. Well, just use the... Oh, actually, use Tesla. TESLA. No, it still requires case sensitivity. Okay, well in that case then, use the naming convention, right, of the 3D controllers. So in other words, just use grep and then put the P100 in there, or your card number, and then you'll find out that whether or not they're connected or not, and the bus which they're connected to, right? So this is the bus number. So that's very important. And in my case, it seems like both are working, which is good. So I'm assuming that that's fine, and we'll carry on. So what we need to do now is we need to git clone the repository, which in my case is VGPU 515. And there appears to be a weird error here, which is the Polo Loco repository name, which has 0 instead of a O. So what I'm going to do is I'm going to cd into the OPT folder, and I'm going to correct the name so that way it reads what it should be, which is an O instead of 0. I think that's just a spelling mistake on the author's end. No big deal. Okay, there we go. Next thing to do is to install the Rust compiler. So here we go. And I don't think this is going to take too long, which is great. So I'll come back when this is done. Okay. So we have installed our Rust compiler. And now what we need to do is ensure that we source the path, right? So we've got to make sure that the variables which are needed to actively compile the binary, or the library in this case, which is our VGPU unlock script libraries, we need to ensure that the variables are used so that way they can be used in the compilation. So here's what we're going to do. We're going to copy this code, which is source, and what I want to do is check my env, and you want to check that that is included in our path, right? Because it says source home.cargo.env, right? And it says make them available in our path. So if we check our path, so home for me, let's do $home, is root. So root.cargo, and I don't see env there. That's interesting. I don't see env. Okay, so let's have a look at this again. Does this actually exist, first of all? It does, right, okay, so it does exist. It's a Rust up shell setup. And it is pre-appending in a case, right, okay, so that's the catch-all, right, okay, so we've got the catch-all and our if condition from the path, right, okay, that's fine. That's fine. So cargo.bin.cargo end. It should be on our path. So let's just check for sh bash. Yeah, so it says home cargo end. Poor fish. Okay, and it looks like we've copied it through, so I'm going to copy this again. Okay. Although I don't see that within our environment, which is slightly concerning. User, yep. Okay, that should be fine. Although there's nothing to really tag it onto, which is all just key value pairs, but there's no kind of real tag, although it says we should see it within the path, but this is not an appendation to the path, which is interesting. So let's do $path and see if we get anything. Okay, so we get cargo bin, all of these things. Interesting. So I see binaries, I see cargo bin, but not the file itself. So I think it should say $path on it as well, but according to the script it says it doesn't need it. So in that case, what I'll do is I will settle with what the script says, make sure that this is definitely sourced, which it is. Okay, and I'll proceed on to the next step, which is the VGPU unlocker. Okay, so we're going to cd into that, cargo build release. Okay, let's see what it says. Now I usually get unknown variables, which is these ones. And it looks like signature, profile size, VGPU, extra params are the ones which aren't recognized, which is interesting. Now normally that doesn't matter, so that should be fine. Okay. Next thing to do is create the directory and the file. So directory, file, touch override profiles. And I'm just going to double check that my LSPCI is still working, because I know that this card does have some tendencies to not work when I need it to. Yeah, that's all good, so that's fine. Okay, now the next thing to do is create our systemd folders, and the reason why we create the systemd folders is that we want these services to be available on startup, and that's what the systemd, in this case the services, that's what they are doing, right? So they're saying, so we're making these folders, VGPU, NVIDIA VGPU services, managers of these particular services, and then what we want to do is add these shared objects which control the startup for these particular scripts and other things, of course, but you want them to be loaded when the system dies. That's essentially what these are supposed to be doing. Yeah, so in other words it says create the folders and files for the systemd to load the VGPU library when starting the NVIDIA VGPU services. So that's what we're doing. Cool. Add them in. Now, enabling IO MMU, so this goes back to the BIOS. When we looked at the 4G decoding, and we looked at SRIOV, and we looked at two other parameters as well, but both of them escaped my mind. So in that case, all we need to do at that point is then update grub, so that way we have the needed IO MMU commands, and then we'll update grub that way. So in my case, nano into that. I like to use Vi, but on this system, Vi doesn't work that well, which is fine. It's just that it doesn't have the Vim package which I need in order to do it. But I could use NeoVim to do the same thing. But so this is okay. This is not too bad. So add that in after the command line Linux default. That looks good. Let's see if I've got one space between. I do. Okay. And that is fine. Yes on that. Update. And we're going to update grub. Shouldn't take too long as well. Yeah, that looks fine. And yeah, that's fine. We don't have systemd on this system because we didn't install using anything other than ext4, which I believe is related to that. Yeah, if you have ZFS, for example, there we go. Yeah, and UEFI, and in UEFI mode. So I'm in UEFI mode, but I didn't use ZFS, so that's why we have grub. So next thing to do is load the required kernel modules. And we'll do that with that. Blacklist. And we've got Nouveau drivers in. Yep, that's fine because we're using NVIDIA. Nouveau is the default display driver, which is installed in things like Ubuntu 22.04 if you want to use displays. I've been told this is going to change though. They're going to go with NVIDIA as the default display driver. At least that's what I've been told and I think is correct. I'm going to double check. I know that there's a guy on YouTube who goes through this in a lot more detail. But yeah, for the time being, it's going to be Nouveau, and we need to blacklist Nouveau from loading. So we'll do that. And now we need to update init ramfs. Now this bit is interesting because you will get, it's not an error as such, but it's more of a message, but it looks like an error. And I'll show you what that looks like in a minute when this loads. So in the meantime, I'm going, oh here we go, it's going now anyway. There we go, it says no kernel, Proxmox boot UUIDs. So there's that. Alright, cool. And then we need to reboot the system. And there's one bit that I want to check before I reboot the system, just to ensure that it's there. And this is on the master branch because this is quite an important change. But essentially, it's a part which is down here for enabling IOMU. And this disables the unlock part on a GPU that already supports VGPU. So we already support VGPU on my system, so I'm going to add this in as well. Okay, cool. And yeah, I think we should reboot. And before I do, I just want to do an LSPCI, just double check that the cards are there still. They are. Okay, reboot. Okay, there we go. Alright, I'm going to pause the video here and get back when the system's rebooted. Okay, welcome back. So I've restarted the system, I've logged in, and I've checked to see that my GPUs are still there, and they are, which is great. So the next thing to do is check the IOMMU is enabled. So we use dmessage, which is kind of the kernel level output of things which happen. In fact, rather than me saying what it is, why don't we check the man page? It's not really good me saying it, but is it what I think it is? Yeah, so it's kernel ring buffers. So in other words, it's kernel output from the system, and what we're doing is we're checking to see if DMAR and IOMMU is enabled. So let's have a go at that, and we can see that within our system it is indeed enabled, and there are certain things which are explained here by AMD that support that statement. Now the tricky bit, the actual NVIDIA driver. So in my case, I have it loaded here in a zip file, which I've downloaded from the NVIDIA website, which I showed you a little bit earlier on. And now what we need to do is we need to install zip. So sudo apt install zip. Okay, I'm going to type Y. Cool, and before I do anything else, let me just check the page. Yep, so after downloading, extract the file, the zip file, and then copy the driver and VGPU version from the host driver folder to the Proxmox into root. Right? Now I've transferred the whole thing, so all I need to do is I'm going to mkdir nvidia, and what I'm going to do is copy the NVIDIA driver package into NVIDIA, and I'm going to unzip it to allow it to inflate essentially. Okay, and as it's doing that, what I want you to pay particular attention to is the host drivers and this one here, right? So we'll do an MV, and we'll put this here, which is our current working directory. That's what the dot represents. And then what we need to do is, we don't need to run that just yet. And then finish rebooting. But if you don't, I mean, I have one which supports VGPU already, but it works with the patch anyway. Although it's not necessary as it says. But I think the patch makes more sense, really. So after that patch, so what we need to do is change the permissions. So we're going to chmod, and that's exactly what chmod does. In this case, it's going to add chmod onto the user group and the other section. So in other words, it will add a flag which refers to an octal. I'm trying to remember what the octal is now. It's not 4, I believe it's 1. I believe it's 1. Because 7 is all. So, yeah, in other words, it adds the execution bit. So, chmod plus x, hello, plus x. And we're going to add that to the NVIDIA run. And we need to change this line here. So what I'm going to do is I'm going to NVIDIA, sorry, not that one. We're going to do NVIDIA that one. There we go. And then we're going to apply the patch. And we're going to change that. So it says VGPU 5.15. And then what we need to do is look for the version of the patch which corresponds to the version of the driver. So in my case, that's 5.3.5.161. So what I'm going to do is make sure that it exists by tab completion. And as you can see, there we go, 161.05 patch. And that's the reason why I copied this repo, is because it has a particular patch. I'm going to run it. Wait for the patch to be completed, which won't take too long. There we go. And the next port of call is to check if this has the execute permissions. So what we want to do is just do an ls-s on it. And yes, it does. And then what we can do is install the driver using dkms. So we don't need, oh, this is the wrong, we don't need kernel there. We can in the 8.2, but we don't need that one there. So what we need to do is just go down a little bit, and I've done that already, I've done that already, which is all good. So the next bit is dkms down here. So NVIDIA, and then we need the .run. Oh no, that's not right. That's not right. See my mistake? I needed that one, which is the one with the driver. So that one there. And then we need to run dkms on it. Okay. Run that. Allow it to build. And it will ask us for a prompt. And that is the exact prompt. So it says, would you like to register the kernel module sources with dkms? This will allow dkms to automatically build a new module. If you install a later kernel, if you install a different kernel later, and it's yes. So we're on yes, we'll say yes to that. That will then install the driver. As such, it's now complete. Click OK on that. I'm going to do an LSPCI just to make sure that the cards are indeed found and we haven't been lied to. They have, which is great. And now the next port of call is to reboot. And once this reboots, we'll then run the nvidia-smi, which is the interface with the driver and the card. Okay, see you in a bit. Okay, welcome back. So I've checked that the cards are there through the lspci command, and then I've run nvidia-smi, and as you can see, the Telsa P100 is indeed found. And this is why I've come to the conclusion that adequate cooling is necessary, but the trick here is to see whether or not the mdev types work. And it returns nothing. Why does it keep returning nothing? Okay, and it should have shown us this particular output. Right, okay, I'm gonna investigate that. So, an update in developments. So I found something very interesting about mdevctl. So if you do what I did, which was have one card with power, one card without, but still within the motherboard, it will be registered within general CTL. So this is general CTL. This is where kind of all the messages get sent in terms of the system, what it's doing, get sent to general CTL. And then I did a bit of a scroll down in general CTL to see if there's anything which is a bit odd. And it came up with saying, well, you need to power it up first. But notice here, which is quite important, it's the NVIDIA VGPU manager service. So this is the service that we created in order to start the VGPU unlock service. These are the services which are related to VGPU unlocker, sorry. And it says that it was unable to find the device essentially because there's no power. So it's very important that if you don't see anything within mdevctl, don't lose hope. Have a look within general CTL and see if there's anything there. And that was the reason why, for me, it wasn't working, because as soon as I tried that, what I did was I did an nvidia-smi, which was the part that we had to look at, but it wasn't working. We only saw one GPU, which is, I mean, it's working, but it's only one GPU, right? But because it's saying we need two, right, we need to ensure that there's two here, in my case, and then look for the mdevctl types. Then it started working because the services are now up. So if I was to do a system CTL, now if I was to do a system CTL status, it will say running, but when I run this before, it said degraded, right? So there's a couple of things that you can do to help in terms of debugging this particular problem. And I hope that's proved quite useful, because I have not seen many people go into the debug phase. So I think that's kind of invaluable to kind of understand, oh, you know, where did it go wrong? You know, have a look at the system CTL status. Okay, you know, it should be running with nothing failed in terms of the jobs, because these are all the ones that we've done. And the general CTL will tell you the name of the service. So we created two services there. So to reiterate, NVIDIA GPU Manager Service. And if we look at the... I didn't realize I was recording with this on. But anyway, so if we look at the doc, there's two services that we create, right? So the one that we created was here, which is NVIDIA VGPU.service.d, and we have NVIDIA GPU Manager Service, right? So these are related to the unlock types. So yeah, that's pretty much how you virtualize in terms of the host. In the next section, we'll go through the installation of the driver inside of the VM, and then we'll also add the programs that we need and the remote desktop stuff to get it all working. And that will be the Windows side, and then we'll go into the Linux side in a later video. I think this video is getting quite long now, so yeah, let's keep that there. All right, cool. See you in the next one. Okay, welcome back. And over here, what we have is that we got VM VR1. So what I did was I went to create, and I went to Linux Bridge, and then from here, what I found was that there's a number of different ports that I have available. So in my case, these are the fiber optic NICs that I have, and this is ENP heading in F0, F1, F2, and F3. So what I found to be quite interesting is that the Linux bridge itself is essentially like a switch. So my understanding of it is like a switch. And what I've done is I've added the ports onto this particular switch, and of course I can set the PV ID on here as well, but it's not listed for me in the section at the moment, which is fine because I can set the VLANs when I create the virtual machine.
Yeah.
So in my case, all I need to know now is whether or not those particular interfaces are up, and according to the system they are, but in my switch they're not. So I've done this before with my other configuration, which was my pfSense one, right? So if I look at my configuration, I can do a show run. In fact, let's go from first principles, right? Okay, here we go. So I'm going to type in my username and password, and then I'm in user mode. So I'll now go to enable, which is enable configuration. This is not global. This conf T is global configuration, but this is the step before global configuration. And essentially, from here, I can do a show run to remind me of what the configuration was, because I don't remember myself. And I don't have it here because I used a different kind of command. But that's fine. I can find out. Split command. And oh, you're right. I remember it was a speed command. Right. Okay. So first of all, let's check the status. So in Arista, it's show interfaces status, and this shows you the status of each particular configuration. So sorry, each particular port, and each port that I've got is running at 10G, which is correct. And I've got a couple of them here where I have, for example, 51.1, which is running at 100G. But it doesn't need to be running at 100 gig. I need it running at 25 gig. And it says it's not connected, but I'm going to just double check. It should be, and one of them is connected, but I'm just trying to remember which port it is. Let me find out.
Oh, is it not code?
It is on 51. Okay, so 49.51. So let's check 51. Oh right, yeah. So 49's there. So 51.1 is what's there. So it's not connected. That's just not correct. So what do we need to do? Well, first of all, let's enter global configuration, because if it's anything like Cisco, it'll be in global configuration where we set interfaces. So conf T interfaces. Or more precisely interface, and then we'll go to 51. Pretty sure it's 51. Interface 51. Check the speed. So there's a speed command here somewhere, and I'm trying to remember if it's in here or not. Let's check. Speed is definitely there. So speed.
Yeah.
And then question mark, and that gives us our configurations. And what we want is 25, but full duplex. But we want auto negotiation. So, wait, do we? No, we don't. We don't want auto negotiation. What we want is 25G, full duplex over one lane. We want 4 lanes. So, 200G, 10 gig half, 100 gig 4. So there should be a 25G4 on here as well. B25G, I'm going to try it 4 because it's 4 lanes. Doesn't seem to like it. Okay, so what about 25G? Alright, let's do a show run. And I wonder if it split the interfaces. So we've got 51, 2, 3, 4. Yeah, that's exactly what we want. And we want to force... Wait, do we? Yeah, 25G full. So I've done that before as well. So 25G full. Okay, and that's it. That's essentially what we want. So now if we exit out of that before we save anything and go to show interfaces status. So show interface status is the same as show IP in brief in Cisco. It's exactly the same command. Let's just see. We should have one port now enabled because we set the speed. And I can see that we do. It is 51.4. and that's exactly what we want. So that's the configuration essentially in terms of that. And then we can set the VLANs as well. So for example, I've got switchboard trunk allowed VLAN blah, because that goes to the servers, and essentially that's the way that we set the VLANs, by setting the trunk mode on. So this is in layer 2 configuration, because VLANs are at layer 2, and this is not an SVI based system where I would have the interfaces up. So what I'm going to do is I am going to save this. So if you're on Cisco, that would be a WR. If you're doing your CCNA, that's a cheat, don't use that. What you should be doing is copy running config, start config, and then allowing that to rest. In other words, copy, and that's pretty much it. So that's that part done. Next part, what we'll be doing is we're going to be setting up the VM so that way it runs within my specific VLAN. So I'm going to just take a bit of time out to just think about which VLAN I want, and then I'm going to set up the VM and the VLAN within the virtual switch on the other side. I do wonder if there's a better way to do this. For example, in layer 3, I don't know if there is a layer 3 protocol which Proxmox uses. If it does, that'd be pretty awesome, because I can just send all the traffic down from DHCP on 2 different. Well, it will know about all the routes essentially by using a routing protocol. That's what I'm saying. I don't know if that is a thing within Proxmox, but it looks like it's possible in some capacity, perhaps with an external package, but we'll see. Alright, cool. So that's that part done. Hello and welcome back to this recording. So in this section of the video, what we're going to do is we're going to create the virtual machine, and we're going to pass through the graphics card into the virtual machine, install the driver, install our programs, and then that will be pretty much the ultimate video editing server done, which we can remote into from anywhere that we want, given certain parameters. So first things first, what I did was I went from a 100 gig interface into 25 gig for different ports. So in other words, I split the port into 4 lanes, and these are all 25 gig. And then from there, from that 51 that we had earlier, I created the trunk between the switch and the server, and then I've allowed VLAN 5 traffic into the VM, essentially, into that VM through a bridge, and then assign that to the virtual machine, right, in terms of the DHCP addresses. So that's been pretty cool. Now the next part that I need to do is, when I've installed that card in, the E810, what happened is that there is no VM bridge. So what we need to do is we need to create the VM bridge in order to allow the traffic to go through. So here's what I did. I went down to network, and what I can do is I can create the VM BR0. So in my case, that's the Linux bridge. And the reason why we create a Linux bridge is because the Linux bridge is essentially like a switch. And what I've done is I've assigned ports onto that switch. In my case, it's VM BR1. That's my actual switch, essentially, within Linux, within the config. And within here, I've activated VLAN mode, right? So VLAN aware is very, very important. That needs to be checked when created. So in other words, what I did was I went to Linux bridge, put it in my bridge, put in VLAN aware, and then you see these different ports here. These are the different ports which are on the NIC. So FF0, F1, F2, F3. I've assigned that into my Linux bridge, which is down here in terms of the ports. And from there, I've created that bridge, right. So the next thing to do is we need to create a virtual machine. So you create VM, and in here I can just say 101. I can say this is a, I don't know, test 2, something, test 23, why not, test 23. And the resource pool is default, because everything's running on my particular hard drive. ISO image, I have a few down here. I'll select this one as my ISO image. I'm going to go next, and then I'm going to go from machine. For some reason this is on i440FX. This is an old style machine. In fact, this one is PCI, I believe. And what we want to do is we want to change this to Q35 in machine type. BIOS, we want UEFI. EFI storage, I'm going to click on my local disk. And the SCSI controller is fine at VirtIO. The disk. The disk itself, I'm going to click SATA. I'm going to do SSD emulation, and I think for our disk we'll have 200 gigs. That's fine. I'm going to be deleting this later anyway, so it's fine. Our CPU, well, this is a 32-core machine, so I'm going to assign 10 cores. I think 10 cores is more than enough. And I'm going to assign 16 gigabytes of memory, right? So let's do 8192 times 2, and that's 16384. 16384. There we go. That's about 16 gigs. Next, we're going to use our bridge. And remember, our bridge was VMBR1. And what we can do now is assign the VLAN tag. So remember, back in the switch config, even if I don't select a VLAN, it will technically use VLAN 5, but as an access. Now, I don't want an access, I want a trunk. So in that case, why don't I just assign the tag as being 5? So let's do that. Now, in terms of the model, I had a slight start there, that was interesting. The model for the network, you want this to be on VirtIO because if you have 10 gig or above, that's the one that's going to give you the maximum throughput. VirtIO gives you 10 gigabits per second. Now, VMware VMXNet 3, there we go. That one I think can do 25 gig plus. I'm not entirely sure, which is a bit ironic considering I have a VMware system, but I will need to install additional drivers. For the VirtIO system, it will handle our needs for now because it's 10 gig plus and we have 25 gigs to play with. We don't use Intel E100, it's 1 gig. Realtek, that's 100 megabytes per second, and that's just not enough. So for this case, we'll use VirtIO. Let's click on next, and let's ensure that we have our graphics enabled. Right, now what do I mean by that? Now let's go back to that virtual machine, right, once it's finished creating, which is 101, and then we'll go to hardware. Now notice the display is default. What that means is that when we create the virtual machine, we are going to access it through the console within Proxmox. That's what that means. Now, when we get our NVIDIA profile allocated onto the machine, what's going to happen is that we can then take out the default because we don't need console access. So that's what's going to happen a little bit later on. But for now, we need it there in order to install Windows and our applications. So here's what we're going to do. We're going to add, we're going to go to PCIe devices, and we're going to check to see whether or not our GPUs are being passed through. In my case, this is the P100. So let's look for the P100, which is down here. We have C3, and we can now check our mdev types. Now for me, this looks like it's a clean installation, as I passed in my other P100 into the VM ID of 100. So for me, what I'm going to do is I'm going to click on the 8 gig profile, because that's probably going to be more than enough to get about 8K, sorry, 8K? 8K would be fantastic. 4K content into our VM for ingestion over 10 gig connection. So here we go. I am going to select PCIe for the advanced settings, and I'm going to click on add. Now, we're not quite done yet, but bear with me. What we need to do is pass the argument into the virtual machine. Now, let's see if I get the terminal. Thank you. Now, the way that we do this is that we SSH into our Proxmox environment. Okay, SSH root at my IP. And for me it's 10.249. Okay. And we need to find the VM ID. So the command that we run is vi or nano etc pve qemu server, and then the VLAN, the VM ID. I was going to say VLAN ID, but it's the VM ID. And I want to show you one from a previous example because I need to copy this anyway. It's this args, right? Args. So I'm going to copy this, and I'll have a link to that in the description below as well. And what we need to do is we need to say that 101. We're going to use nano for 101, and then we're going to click, which is the right click, and I'm going to change this from 100, so you can have 100 to 101, right? If you've got 1000, you go to this column, 10,000, you get the idea. Okay, cool, so let's click Y on that, save that. Okay, I think we're pretty much good to go. Let's just check our bridges passed through as well. Looks good, looks good. Okay, cool. I think we're in a position where we can now fire up the machine. Start. And I have a UEFI image, so this should be fine. Yep, there we go. Okay, so what I'm going to do is I'm going to install this machine. Okay, now I'm not going to bore you with the entire installation. I don't think there's any sort of value in that. So what I'll do is I'll install the machine, and once it's installed, I'll come back and show the installation of the driver and some of the programs that we need to enhance our experience. Okay, I'll see you soon. Okay, so one important bit that is good to know is that when you use VirtIO with the standard Windows CD or ISO, it will ask you to connect to a network, but you don't have one. So I'm going to click, I don't have an internet connection, continue with limited setup, I don't need all that stuff anyway. And it's going to say hi. Or maybe not. It's going to say Proxmox. So, yeah, we'll add that back in. All we need to do is just add a disk and it'll be fine. We'll just wait for it to load and then we'll do that. Connect to a network. I don't have a network. Continue with limited setup. And then it's going to create a local account. So I like to use test for local accounts. And it's a bit easier for me to use as well. In terms of, oh, the memorable word. Type anything. It's test, who cares? Wait, did I just... Oh, I did. Okay, password is test. Test. Security question can be whatever. Doesn't matter. It's only a demo. Okay, yeah, so that's what we wanted. We wanted a local account. Let's get rid of some of these screens. We want the windows to come in through now. Okay, still doing that stuff, so I'll unpause. I'll pause the video and unpause when this is done. Okay, so here's what I'm going to do to... Okay, so here's what I'm going to do to get the network card to work. So, first thing that I want to do is I want to shut down the machine. And then the next thing that I want to do is search for VirtIO drivers. Proxmox VirtIO drivers Windows, and then we'll look for the very stable version, which gives me 0.12 E810. And I already have that copy, so I'm not going to worry about it. But what I'll do is I will have that link in the description. And on top of that, I will also add the disk. Like that. SATA, storage, ISO really, and it's that one. Okay, and I'm going to click add. Fire the machine back up. Okay, I'm going to pause the video while it loads. Okay, I'm going to go to this PC. I'm going to click on that IO, and then down here, x64, next, 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 install. And, all being well, come on, install. Okay, I've got one more yes. Okay, fine. Come on. Come on. Yay! There we go. Sweet. Right. And let's check the speed. Why are you doing this to me, Edge? Why? I was really happy. Okay, I'm leaving that in. Right. So exit out of that. Go here, and then we're going to click on network. That's what we're going to click on. Network. View. Network. So there we go. Network Advanced Sharing Center. Properties. And in here, I think it shows the speed. There we go. Yeah, link speed 10 gigabit per second, which is exactly what we want. And we can kind of test it in a very strange way because I have gigabit internet. And with the Proxmox project, I can also test it that way. Okay, so here we go. What we're going to do, we are going to go to speedtest.net. And the internet works, which is great. That means DHCP is working. Speed test. Speed test by Ookla. Reject all. Go. Okay. So what we need to do now is we need to install the NVIDIA driver, right, for the P100. So how do we go about doing that? Well, what I like to do at this stage is activate remote desktop. So let's go ahead and do that. So remote desktop, we go to settings, and I'm going to just search for remote desktop settings, enable, confirm, and all looks good. I'm going to go and remote desktop in that way and check the IP before I do. So cmd IP config, and I get 5.4 as the lease. So I'm going to click on 5.4, sign in with my user, and there we go. Okay. Next thing is we're going to set the network to be static because it's a bit easier to work with a machine which has a static IP address. So network and sharing sensor, properties, and we're going to edit the assignment to static, which is manual, IPv4 192.168.5.4 in my case, /24 mask, gateway 192.168.51. For DNS, same, because that's where the pfSense system goes. Save. What is wrong with that? 192.168.5.4. That looks fine. That looks fine. That looks fine to me. 168.5.4. Click one or more settings to try again. So 252.5.2.50. That's right. Not sure what's wrong with that. It looks all fine to me. Okay, let's try a different way. Okay, I'm going to try a different way. So in my case, I can go to control panel, large icons, and in here there is another feature that we can use. Let me just think. I think it's network and sharing center. Yeah, here we go. Network and sharing center. Change adapter settings. I'm going to click on this one. Properties. PV4, and we'll do it from here. 192.168.5.54. Okay, and 5.1.5.1. Okay, cool. Next. Might get momentary loss, but it should be fine. Just check on our terminal. Okay. Yeah, that looks good. Alright. We might need to restart our RDP session. Yeah, we need to restart our RDP session. Okay, let's restart the RDP session. Test. Sweet. Okay, so it's good. We got 2 parts down. Now we can install Parsec and the NVIDIA driver, but I want to do this first. Cool. Per user is fine. I've only got 1 user, but if you've got multiple users logging in, use shared. And while that's happening, what we need to use also is we need to use a VB script. Parsec's loaded, which is great. And this is, I think it's called VB audio, and you'll see why in a minute. So virtual, is it called VB? VB virtual audio. There we go. Video audio software. So this is a virtual cable, and essentially what this is this, when installing Parsec, allows us to pass through the sound, and that's the reason why you want the driver. So that way we can install it as a virtual sound capability, and then this gives us the ability to hear stuff when we use Parsec. Because, well, I'll show you. It's easier than me babbling. Okay, let's install this. Okay, and that one. Install. I need to start it as administrator, which is fine. Yep. Install. Nope. Install. And we need to reboot, which is fine as well. But before we reboot, I just want to add the guest driver for the GPU. And the way that I'm going to do that is I'm going to copy and paste it. So I'm going to go to this PC, and it's in my game system. NVIDIA driver, backup, 7.1, 16.5. And it is under VM guest driver. You won't have this initially, but it will be included in your NVIDIA Grid download. So when you download from the link that I mentioned before, the NVIDIA driver download link, you will then get access to that driver. And the way that you find it is if you go inside, it's on the guest driver, and it's this one here, which is the driver that you're looking for in terms of Windows. And of course you've got the associated Linux ones as well. So I'm going to go ahead and transfer the driver, which is under VM guest driver, and I'm going to copy that into our virtual machine, which won't take too long. This is over 10 gigs, so this is pretty damn fast. And I'll come back when that's done. Okay, so we're here, copied it over. Now I'm going to reboot the machine and then I'll come back. Okay, next step is to install the grid driver. So this is pretty cool because if I run as administrator, it works pretty much straight away, which is pretty cool. And you'll see what I mean in a minute. So we're going to install it and you'll see that it just runs, which is pretty awesome. So I'm just going to wait for this part to be done. And okay, it's going quite quick. I was going to pause the video, but it's going quite quick. So you'll see what I mean in a minute. And this is the moment of truth where it checks the compatibility. And just like that, it's pretty much there. So I like to do a custom install for any installation of the driver. And the reason for that is because it generally comes out a lot better. In my experience, it cleans up all kind of unnecessary directories as opposed to upgrading. And it just makes the experience a lot nicer when we install the graphic card driver. So it usually doesn't take too long, but yeah, we kind of need to sit through it. And then this will give us the ability to then use the driver in our editing suite of DaVinci Resolve or Premiere Pro or whatever it is that you're trying to use really. And that's pretty much it for the video, because at that point you're just installing the programs that you have. Well, okay, that's not exactly true. The next part is actually to set up Parsec. And then we're done. So that's installed, which is great. Let's check Device Manager. Make sure everything's there. Yep, so I've got Parsec virtual display adapter, which we don't need actually. We don't actually need it. But I can see that we've got some display adapters, which is pretty cool. So I think that's fine. Parsec. So what we need to do now is log into Parsec. I'm going to do that and then I'll come back in a second. Okay, so I've logged into Parsec and this computer is showing up now, which is pretty good. I can see like one of my other computers, which is the one which I'm on. And let me check the name as well, because that's a good point actually. I didn't check the name. So click on this PC. And then I think another thing we got to do is change the name of the PC, make it a bit easier to identify. So I'm going to go here and it's 5ATSF, right, okay. 5ATSF, there we go. So that's the computer that we have. Click on connect. And we should, in a second. Okay, because I'm on remote desktop. Okay, so let's get rid of remote desktop. Let's connect that. Connect this. And we should be able to, yeah, log in. And initially it comes out all fuzzy like this, which is interesting. But after a while it comes out quite nice and clear. But what I like to do as a little hack is I like to set the bandwidth to 50, because I've got the bandwidth at at 10 gigs, so we're pretty much fine that way. But here's a cool thing. See that virtual cable? We got sound. We got sound, which is pretty cool. So yeah, that's that. The next section next section is to go back to Proxmox, and from here we need to get rid of the default display by shutting down the machine. So let's shut down the machine. I can just remote desktop into it. It's a bit quicker. just wait for it to shut down. Shouldn't take too long. Okay, shut down. And set this to none, because that's a primary graphics driver, but we don't need that, right? Because you're already sharing the GPU. So now what we can do is we go back to Parsec and enable the system. See, because we can't connect now because the VNC console has been disabled, the primary one is out. So we need to just start the system. And then we need to wait a little bit. And it should come back. And if not, then we can put it back in again and see what's going on. But usually this should be fine because we set the static IP address. So we should be able to, and if not, actually no, we won't be able to see it on here. We won't be able to see it in Parsec. We will be able to see it in remote desktop, and I think the reason why is because Parsec needs to be running on the other side. Yeah, it's not running. So if we go to remote, that one, that's not running either. I don't know why. 5.4 should be fine. Statically assigned. Oh, there we go. Spoke too soon. But yeah, looks like Parsec's not running on the other side. So, should be able to... Yeah, it's not running, so that's the reason why. I think we might be able to control alt delete. Let's see, task manager. More details. Startup. Parsec is enabled on startup. Okay. Interesting. Oh, there we go, it's there. Just had to wait. Okay, sweet. And now we can connect. Okay, test. And if you go to device manager. Okay, Parsec still there. I don't think that's necessarily a problem. See if you can find it automatically. It's already installed. There's a slight issue with it. Code 31. I don't think that's not a problem. I don't think. So yeah, that's pretty much the installation. We've got our graphics card driver in, which is great. I don't think we have... Yeah, I don't actually think we have another... Do we... Okay, next thing to check. Next thing to check is our display. So we want to check our display settings and make sure that we are running off the... There we go, the grid driver. And we are, which is great. Which is great. So we don't even need to set any other displays because we're running off the primary display driver of the grid. Which is great. So the next step is really just to install your programs, and that's it really. Pretty much done. Okay, so I hope you've enjoyed this quite long, quite lengthy, quite in-depth session on VGPUs in Proxmox, as well as setting up a AOC with 25 gig and the switch configuration. Hope it's been useful, and I'll see you again soon. Thank you, and bye-bye.